Now we're going to write the formula for KMnO4. So if we look at this, we see first of all that we've got all kinds of different elements here. So we want to separate out our cation from our anion. Just a reminder, a cation has a positive charge, and then the anion has the negative charge. Well, I can separate it just like this. And I notice that my cation is potassium. I can look on my periodic table, see that potassium has a +1 charge. It is not multivalent, so I do not need to use a Roman numeral, and I will not have more than one name. So I can go ahead and write potassium here. Alright, but now I see over here I've got this MnO4. And MnO4 is the polyatomic ion permanganate. So I know I've got a polyatomic ion here. The name is permanganate. So just a reminder how to write this name. Some of you already know that it's going to be simply potassium permanganate. But just in case you're not sure how I got to that, I can use this chart here. And I can ask myself, okay, what bond type do I have? I've got an ionic bond that involves this polyatomic ion. If I come over here, I notice that my cation is not hydrogen. My cation was not multivalent because potassium just has the one charge. And I come down here, do I have a polyatomic ion? Yes, I do. So the way that we name polyatomic compounds is just very simply, you write the name of your cation and the name of your anion. So this example that we have is sodium chlorate, NaClO3. Cation is sodium, and then ClO3 is chlorate. The one that we just did a minute ago, we have cation potassium, the anion permanganate. Now, if you're allowed to use a chart on your test that has polyatomic ions, then you consider yourself lucky. If not, the only way to know these is just by memorization.